Hi everyone and welcome. Today we're going to be looking at some properties of isosceles and equilateral triangles. So your goal after watching this video will be able to correctly identify and apply the theorems and properties of isosceles and equilateral triangles. So let's first start off with a reminder of isosceles triangles. They are triangles with at least two sides that are congruent. The angle formed between those two congruent sides, we call that the vertex angle. The two angles formed by the base of one of the congruent sides, we call those the base angles, surprisingly. So again, the one that's between the two sides is our vertex angle. Our two that are across from those two sides that are the same, we call those the base angles. The isosceles triangle theorem tells us that if two sides of a triangle are congruent, then we can also expect the angles opposite those sides to be congruent as well. What that means more clearly is if we draw a line from the side directly across from the angle, we expect, again, those two angles across from those sides that are the same to be also the same. So a fancy way of just saying that if you have two equal sides, you have two equal angles as well. So we can say here, angle A is congruent to angle C because the sides across from them are the same. In this case, angle B, this is our vertex angle. Angle A and B, A and C, these are our two base angles, so applying some things from those definitions directly here. So right after this, we're going to have opportunity to apply our knowledge of these isosceles triangles and the properties of the angles that are equal. So for example, number one, again, try to apply some of the knowledge we just took from there directly to the example number one question. All right, moving on here to our next theorem. If two angles of a triangle are congruent, then the sides opposite those angles are congruent as well. So this time, if we are given angles first, we can say that the sides across from angles that are the same are also the same. So before we went from sides to angles, now we're going from angles to sides. So in this case, if we know that angle D is congruent to angle, we'll call this one F, I know it kind of got cut off in the photocopy there. We can also say that the sides across from them are congruent as well. So angle DE is congruent, side DE is congruent to side FE as well. Just saying that these sides here and here across from our base angles. So again, base angle here, vertex here. Sides across from our base angles are congruent. So in this case here, we want to label some of these parts, label some of these congruent angles based off of what we see. Here we have a base angle, so we know that the side across from each of those base angles, that these sides are going to be the same. So we put two dashes there. Next, across from these sides that are the same, we know that those base angles will be the same as well. So we can identify now on the side there the congruent angles and sides based off of the labeling we just did on that picture. Next, a corollary here. Sorry, I just got lost in my notes here. So again, a triangle is equilateral if and only if it is equiangular. Really fancy way of saying if all the sides are the same, all the angles are the same, and if all the angles are the same, all the sides are also the same. So basically saying same sides correspond to same angles, or same angles correspond to same sides. We're not allowed to have two sides that are the same without having two angles that are the same. Same thing goes for three angles. If we have three angles that are the same, we also must know that we have three sides that are the same. So again, relating the number of sides and angles to each other, that's what we're focusing on for today. And again, for isosceles with two that are the same to equilateral with three that are the same. And finally, our last note here, each angle of an equilateral triangle, well, they're all the same. So we take the degrees in a triangle, divide it by its three angles, and we get our answer of 60. So we know equilateral triangles always have angle degrees here of 60 degrees. All right, so an opportunity here to apply this. We are taking a look at triangle EFG, saying that it is equilateral, and we are looking for a couple of different measures. So first things first, we know that all angles are 60 degrees. So that means we know that in total, 1 plus 2 add up to 60 degrees. Secondly, we are given that EH is a bisector, so that means it cuts it in half. So that means that angle 1 is also equal to angle number 2. So by that logic, we should know that they both have to equal 30 degrees. So again, cutting 60 degrees directly in half gets us to our 30-degree answer here. So angle 1 and angle 2, both of those equal 30 degrees. And now we can take a look here at the bottom and figure out the remaining triangle, figure out what x is. So we know that angle 1 is 30 degrees. We know that this angle on the side is 60 degrees, so now we can solve for 15x. And again, remember, triangles have 180 degrees. So let's set that up as part plus part plus part equals 180. We have 3 of the parts. Now it's time to list them and solve for that final x there. So a little bit of a shorter video here today, but again, these are important skills to keep, so make sure we're keeping some detailed notes here. We're going to be referring back to those frequently, and be ready to go over some of these questions in class. If you're not sure about any of them, as always, save those questions, keep them for small group time, and you'll be in good